Topic is node modules the problem, and yeah, there is a lot of problems with the node modules, and we'll see like one specific problem. Let's go one step at a time, and let me introduce myself. So I'm Santosh. I work here at Rubrik. Okay, yeah, now it should be right. So yeah, I work for Rubrik as a software engineer, mostly on the front end part. We use React, TypeScript, and a lot of stuff. And yeah, so basically, we have our own prime product, Rubrik Security Cloud. We'll just take a couple of minutes to introduce that. So basically, you can use RSE to secure your data wherever it lives. Like say, you can secure your workloads wherever it runs, like whether it be enterprise, cloud, or SaaS, whatever it is. You can make sure that your data is protected with no tedious processes or no tedious works with backup amendments or so on and so forth. So that's about it. Yeah. So let's see the major focus of this talk. So it's not going to talk much about the greedy disk usage, the size of the disk that it is using, the node modules folder or something like that. Or either I'm not going to talk about the vulnerabilities that is going to be caused by the open source ecosystem or the node packages in terms of the application security, not that also. So what I'm going to majorly focus on is about like the vulnerabilities that is caused on your dev machine or the servers wherever the node modules folder is sitting, right? So basically, we are using this open source thing for Node.js, and we are downloading the code in your local machines using it. And where this node module set, like we need to take care about the security there. So we are just going to focus on the vulnerabilities only on these places, right? So I just want to set the focus right and clear at this point, and let's move on. So before getting started with the talk, I just want to tell you a small story about it. Like maybe Hollywood fans will be able to connect this, but yeah, uh, let's go into that. So there is this node package called UA parser.js. Most of you might have came across or might be already using this package, or might be using the package which is transitively using this package internally. So basically, like this package is one interesting package which has a lot of stars and users in the GitHub, and say there is a lot of stats here. You can just see that. So basically, it is used to extract the browser name and few other user agent related details in a very standardized way. So that is what this UA parser.js is used for, and we use it mostly in the front end part. And you can use this same package in your backend Node.js servers also. So to get the user agent which is sending the request, so that's majorly it. So it has pretty lot of weekly downloads. If you see in npm, it is like currently 7.5 million weekly downloads, which is humongous, and 45k hourly downloads, which boil down to, and nearly 2k dependent packages in npm, if you see. And if you see, like there are 3 million GitHub repos which are using it. Again, like this stats may or may not tell the exact details of how vital this package is, but still it shows up that there is a lot of consumers for this package, and it's one of the most commonly used package in the Node.js ecosystem, right? So rather it be on the front end or back end. So yeah, let's get into it. So the owner is Faisal Salman. He's an open source contributor. So like given all these details, let's get into the story. So on October 5, 2021, so in a Russian hacking forum, there is a post that appeared, which is saying like, say, I have an NPM account, and you pay me $20K, and all said you can get the account. So that account has a repo or a package in itself, which has like nearly 7 million downloads by then weekly. So that's the thing which was quoted, right? So on 22nd October 2021, three malicious versions of this package was published, and obviously you got it right. So basically, it was not Faisal who actually published those packages. It is someone else. The account was compromised, and now three malicious versions are published, right? So what this does, we'll see that later. But before that, right? So like what actually happens here is like whenever you install it, right? So malware get downloaded along with this package. this malware starts executing immediately once it is downloaded. Okay, now let's see how it happened, right? So basically we are like, it's total black box, right? I'm saying that this package got downloaded and everything got hacked or steal or something, right? So basically we'll see what this malware does and how it happened actually. So if you see, right, so basically in each of the package, right, which you are downloading, there is something called pre-install hooks in the script section or the scripts property in the package.json. You can configure that pre-install hook. So basically in there they are executing this pre-installed JS JavaScript. If you see the code, right, it tells by itself, like say, it doesn't do anything much for the Mac OS, but it does something for Windows and Linux, right? So what it does is it does executes a, CMD script like a bat file for a Windows machine, and for a Linux machine it is trying to execute a shell script, right? Now let's see what this actually does, right? So what is inside this pre-install.bat and pre-install.sh files, right? So let's see what this shell script does. So basically it downloads a, a like extension, like it's a executable. It is downloaded, it is downloading it from unknown IP, some random IP, and then just trying to execute it. All right, so now what is happening here? So basically what is happening here is like, it is trying to steal the data from all the apps that are running in your Linux machine, right? So basically we'll see like what is the problem and why it is happening only with the Node.js later. But now let's just focus on this one, right? So in Node.js I can just run a script. From Node.js I can just run a application. I can just trigger running a process from the Node.js script, right? So that is what is happening here. They are just trying to download it and then run it immediately. So let's see how what happens in the batch file in the Windows machine. So it is trying to download it from the some IP and then trying to run that executable. So basically here there are two things which are happening. There is one executable which is it is trying to run, and another one is like it is trying to mine the cryptocurrency also, right? So they like likewise, like there can be multiple stuffs that they can do, but this is what has happened from the code snapshots which has been taken from that releases, the package releases. This is what is actually being done, right? So let's see what has happened next. What are all the reactions, right? So basically after 4 hours, right, the GitHub issue was raised and people got noticed that there is something else is happening, and this author was diligent enough to take an action immediately. That 4 hours time is like uh, pretty small when you come when you think about the open source ecosystem, right? You get a vulnerability and then you get a response or a alternate solution or something like that, or a workaround within 4 hours. It's quite diligent. So the community was diligent enough to report it, and the author was diligent enough to take an counter action for it, right? So basically he published 3 other alternate versions, like say basically the 3 versions if you see which was published, right? So it was like 7.29, 8.0 and 1.0.0, right? So they he just sent out an update of each of these minor versions. So 7.30, 7.8.1 and zero point 0.1, right? So he sent out an update. He sent out a published packages, and then he deleted the packages which was already published in the npm. And then like say obviously CISA came into the picture, and then they sent out an article which is like, it's a agency from US government, and they sent out a article to make sure like uh, to ensure that people are knowing that these versions are affected by the malware, right? So that the people can either first they need to delete the existing malware which is there in their systems, which is stealing their passwords, which is mining the crypto or whatever it is, right? They need to get rid of that, delete it, get it down, delete it, and then again it's better to update the package also, right? So that is why they did it. And again, like say for example, after that 4 hours period, whomever it's trying to download that package, they should not get these packages, right? The affected packages. So that's what the thing means. So let's see what has went wrong later. But yeah, so now what we understood is there is this 4 hours period, right? And now that count which I mentioned, right, hardly downloads, that comes into the picture. There was around 45k average downloads per hour for this package, and think of like how many downloads would have happened in this 4 hours. And that's what has happened. Like already there is a lot of people's mission which was already compromised, right? So this is the end of story. Now let's see what could have done, what we could have done better. But before that, we'll take a look at the stats, right? So basically, like around 1300 packages are removed from the npm in just 2021 a year, right? So basically these are just the packages which are removed because it is secure, like it's not secured, it's vulnerable, right? So like basically you see the split up here. A few are like trying to get the data, like trying to track the data. Say for example, you may think that what are they going to do with the data, but say for example, right, if you think in the perspective of enterprise or any government institutions which are using the node.js, right? So if there is an environment variable which can tell their email id or xyz authentication factor, they are breached, right? So that should not happen. Say for example, if there is anything in the environment variable, it's easy in the node.js to get it, right? process.env, you just randomly give all the variables which are possible, and then you get the data out of it. So basically what most of the scripts in these packages which got removed, right? So what they were doing is they were trying to steal the environment variables, they were trying to steal the cookies from the browsers that are in the mission, the local mission, and a lot of other stuff. And you can see that credential leakages, and they are trying to steal the environment variable, and the split up is there. And you can get a, like say, better idea about these stats and all these things from this paper which is from the Cornell University. So on an average, malicious package is available for 209 days. This is an interesting fact, right? Say the package or the story that we saw before, right? It was like the action was taken within 4 hours, and we saw like for a popular package like that, the 4 hours period is much more bigger, and it is the surface of the attack is a lot bigger with the kind of consumers, with the number of consumers, right? But if you take these packages which are there, like say other packages which are not popularly used or other than that, so they are there in the npm registry for 209 days, and we are highly vulnerable. Maybe we may use it unknowingly, right? So what actually happens there, right? So in the open source, let's take a closer look, and then we'll try to find out what went wrong in that story. So like we download some code, right? We are not reading it most of the times, and it comes from somewhere, like it's coming from npm registry, and we do not know who is uploading and from where it is coming, and written by someone else, and we execute it with all the permissions, with all the permissions in the machine, right? So that's what node.js does. It doesn't restrict any permissions or something, it just runs it with all the permissions, and you are done. So we are running it in our machines, servers, and in number of places, right? So basically where we have all our secrets or sensitive data. So this is what happens. So now let's see why it is not happening with the other languages or other platforms, right? Why is it happening only with the node.js? Is it a node.js problem, or is it a problem with all the open source? Like say Golang is having, Deno is having, whatever, right? Whatnot. So everything is having. Now let's see whether it is an open source problem or it's a node.js problem. It's like a conjunction of both, right? To be frank, it's not like a node.js specific problem. It's not a problem that is specific to open source, right? So if you compare the Deno, which is one of the counterparts for Node, like Ryan, who built the Node, he only built the Deno now. And one of the 10 things he regret about Node.js is like it's not secured. So why he is telling it's not secured is like you can just directly go and get all the environment variables. You can just try to make changes to your file system, write a file, delete a file, read a file, do xyz, whatever you want, right? But in case of Deno, which is one of the counterparts, if you see, you need to execute the script with the corresponding flags. You need to enable the permissions, like say whether the script which I'm running will be able to get the environment variables for a pre-install script that we are running in Node.js. We do not actually require the environment variables. I don't see any reason, right? So you can just use this flags to prohibit, restrict, or do something, but there is no options like that in Node.js, right? So that's why he call it insecure, and that's what the problem is, right? So it's not a Node.js specific problem, it's not an open source problem. So basically, if we are running all, like if we are running the Node.js scripts that are developed by us or internal to the company or institution, then we are out of any trouble, right? So like say we are not going to run anything which is malicious or something, so we don't have any problem. So when the problem is like when you download a code from the open source ecosystem and then running it without reading the code, that's where the actual problem happens, right? So it's a conjunction of both the open source ecosystem along with the Node.js security problems. So it's a conjunction of both. That is where we see these vulnerabilities with the Node modules. So basically, let's just think about, right? So basically, will we be able to live without this Node modules or Node packages that we have? Like apparently not. So basically, like say 90% of the code that we write in Node.js, like we trust on a lot of packages, and 90% of the code, when you try to compile it, right, 90% of the code is coming from the open source packages rather than your application code in most of the applications or servers, right? So we are like more liberally adding dependencies when you compare to any other platforms like maybe .NET or Java or whatever it is. We are more liberally adding dependencies, the open source dependencies, and like when you are adding a dependency, it doesn't mean that you are just adding a dependency for that one particular package, right? It is like you are adding a lot of transitive dependencies also, like say which is like which like say, on an average. So this is an interesting stat again, like say when you install a npm package, like you implicitly trust on 79 packages and like nearly 40 maintainers. So that is like we don't care much about like what dependency we are using, right? That's where the problem starts. So like when you think about this, right, one is like we are more vulnerable to the uh, uh, like say what if the open source maintainer is not there or something like that. But in the security aspect, the surface of the attack is much more bigger. It's not just your application code which can be vulnerable, it is the 90% of the code you are pulling from the open source that can also be vulnerable and that can backfire you. So let's see what we can do to be safe, right? So basically, we need to be more thoughtful, more judicious before adding a dependency to reduce the surface, like attack surface, right? So before adding anything, like even when you're building a React app, don't add any package or any dependency immediately when you want. So just check whether the package solves your purpose first. Go to the README, check it out, and then check whether it has enough GitHub stars. It has been there for a quite while time, and then there is enough activity in the community, whether the community is larger enough to support your purposes, and the security aspects which are mentioned in this one also, right? So beware of the typo squatting. This is one of the popular attacks that are happening, right? So basically what may happen is like say noblox js.proxied. This is one of the famous libraries that we may use, you may have came across. But yeah, like there was another one package called noblox js proxy. So this was published and it is a vulnerable package, and there are like say a high risk that we may uh, like install this vulnerable package instead of the actual package, right? So please make sure you are typing the right like wordings, or the you are typing the right um, package name while you are installing the package to your node app or server, whatever it is. And the next one is like say make sure like say you are setting up the right registry to your internal packages, right? Say for example, let's say the company name is abc, and you have a package xyz. So most probably we will have name something like at the rate abc/xyz, right? So you need to make sure, like say if you are serving it from the private npm registry, you need to make sure that you are setting it up in the package level or in the project level. You need to set the registry. There are problems when you set it in a global level. Say for example, if you set it in your machine, right, it like on a global level it will be set, the registry will be set only for your machine, and it is not say for example a new developer getting onboarded and he's trying to install all the dependencies, right? And think of a scenario where this at the rate abc/xyz a vulnerable package with the same name is published in npm. Okay, so now this new developer who is getting onboarded, he doesn't have this registry mentioned in his mission, right? In a global npm configuration, right? So what happens is he is prone to vulnerability. He will download this vulnerable package and then that's it. He messes up. So the problem here is not him not adding the registry right. It's about the developer who added the dependency and didn't make sure that he added the proper registry, internal registry that needs to be placed in the package.json. So please make sure that, like say, when you are adding an internal dependency, make sure that you are setting the right registry to it. And about like when you need to update, right? So basically, like when we talk about that story which we saw, right? So it's not about the people who actually just installed those packages. It's also about the people who updated to the latest versions, right? Like they didn't see that it is just hours before the latest version has been published. They just went and then updated it. This could be a more vulnerable problem, right? Say basically what happens is, like say, uh, we need to wait most of the times. So let the package be released. Let someone make some POC, or maybe you can try out some POCs. Wait for some time. If there is any known vulnerability or something like that, wait for it, and then don't wait for too long, because there is a lot of exposed vulnerabilities which will be fixed in the future versions and not in the current version, right? So you need to update your packages at the right cadence, like maybe wait for like 3-4 weeks or maybe few months, and then update your packages which you are using. And let's see the shortcomings, like which with the tools that we are using for this purpose, right? So we are currently using few tools, right? Say basically we are using dependabot or snake to identify the vulnerabilities in your react app or any other node.js apps, right? So what's the problem with these applications or tools is, like they have a list of packages which are vulnerable, or the list of versions of that package which are vulnerable, right? And these are mostly publicly listed vulnerabilities, and they have the list of them, and then they make sure that these packages or versions are not installed in your app, right? The problem is, like which we saw before, right? There was one stat mentioning that the packages are mostly like there in the npm registry for 209 days before it is being reported vulnerable. So the problem is there. So like most of the times when it is being caught by this dependabot or snake, it's already too late. So what we need to do is, like we need to have a closer look. We cannot depend on these tools currently, and there is one tool like socket.dev which we can just explore a bit, which can give a better idea. See, basically it doesn't just go through your application code to find out the vulnerabilities. It also go through your packages which you are using, check if there is any vulnerable code, obfuscated code or something like that. You can integrate it with your GitHub apps, or you integrate it as a GitHub app, or you can add it to your build pipelines as well. Just try to explore it. But yeah, the most important thing that we need to do, or we must not skip it, is the manual audit of the package. So go through the package, like whenever you are working in an enterprise grade application, definitely you need to like just go through the packages or dependencies which you are adding newly. Go through the code, try to find out if there is any fishy code or something like that. Make sure that it is clean enough to use it in your project, right? So doing it, say for example, if you have a project already and like say you are just trying to add a like trying to do an audit for all the packages at once, that is going to be a trouble. That is going to take a lot of time. Instead, what you can just do is you just need to do a audit whenever you are adding a package as a dependency to your project. So that you need to make sure. And let's see like what are the major things that you need to focus on a manual security audit of a package, right? So basically you go through the code like literally line by line, and this should happen before installing and then using it, right? So make sure like you go through the install scripts most of the times, basically the pre-install hooks or the install hooks, uh, like more thoroughly, because that is where most of the vulnerabilities are present. That is where you actually most of the times the attackers try to download the malwares and then try to execute it. So just make sure that that is not happening. And like say there is a example here. So if you find any obfuscated code, like as shown in this slide, right, so better stay away from that. There can be a lot of vulnerabilities with this. Basically, you I don't know, like say like maybe if it is a trusted third party, okay, to have a obfuscated code, but not a open source ecosystem, right? So if you are downloading a code from the open source ecosystem, make sure that it's not having any obfuscated code like that. So yeah, that's majorly it. And like say if you want to say, for example, like say you are working on a POC, or if you are going for a hackathon, or if you are working for an interview task or something like that, it's hard to do these audits to make sure your missions are not um, compromised, right? So in that case, what you can just use is, like, you can just try to containerize your applications even for your development, so that you have a abstracted layer which encapsulates the unwanted information being exposed, right? Like say basically it will allow only the scripts to execute only within it, the controlled environment, and not on your exact bare metal. So that is what it does. And say basically, when even if there is a malware that is being downloaded and running, and when you bring down the container image, it obviously is cleaned up and shut it down. So yeah, that's it. That's the major point like that I wanted to make. So basically I wanted to make sure that people who are using this open source ecosystem are out of this trouble of getting into these vulnerabilities. So just keep an eye on it. So basically I just want to quote a uh, statement from Linus Torvalds. So basically he just tells this, right? So given more eyeballs, you can find any of the bugs. So try to just give more eyeballs to all the security related issues. Just make sure that we are out of harm, right? Thanks a lot. Mask up, stay safe. And basically, I want to thank my team also, my manager especially, Vinay, Priyatam. So basically, like, they gave me the opportunity to host the event, and like say now with the support of Girish, Vimesh, and Kavin, like, this event is happening. Thank you so much.